And we're working on the spring 16 final, and I sent this out to you guys. And the first thing we want to do is find the volume for rotating this region about the x-axis. Do you remember how to find the volume from rotating? It's going to be pi from some a to b, r of x, and then we're going to square that. Okay, so what's r of x here? I'll draw an arrow to help you. Anybody want to tell me what is r of x? Don't be shy.
The function?
Exactly. And what do we get when we square a square root? Just the radicand, right? Who remembers how to integrate this? What kind of integration is this?
Integration by parts.
Right, we're going to put the polynomial to the left and the exponential to the right. Remember the acronym IPET? Polynomials to the left. 2x to 0, e to the x, e to the x, e to the x. Plus, minus, plus. Okay, so that's going to give us pi, and we'll have e to the x times x squared minus 2x plus 2. And a to b is, what are our limits of integration? 0 to 1, right? Okay, so that's going to give us pi. Then we'll have e to the 1 times 1 minus 2 plus 2 minus e to the 0 times 0 minus 0 plus 2. Okay, what's that going to simplify to? Those will cancel. We'll get e. This goes to 1 minus 2. Any questions on that? Nope. Great. Okay, the next one is an improper integral. And how are we going to do this one? Anybody?
U sub.
U sub. Let's let u be the log of x so that du is 1 over x dx. And how fortunate for us, here's du. Okay, so this will be, I'm going to pretend like we have an indefinite integral. We'll have u to the negative 2 du. And what do we get when we integrate that? Inverse function, polynomial, exponential, trig. That tells you who goes to the left and who goes to the right. You haven't seen this before? Did he discuss how you decide who goes under the derivative column and who goes under? Yeah, Lee works too. None of these acronyms? Okay, yeah, either one works. They're both fine. All right, so basically you put the polynomial to the left of the exponential. All right, so back down here, when you integrate u to the negative 2.
Negative u to the negative 1.
Negative 1 over u, right? And we can change our limits of integration. Since u is the log of x, we're going to go to the log of 2 to the log of infinity, which is still infinity. All right, now I'm going to make that a limit, and I'm going to pull the negative sign out. So we'll have the limit as t goes to infinity, negative 1 over u, log of 2 to t. And that's going to be the negative limit as t goes to infinity. I have two negative signs there. 1 over t minus 1 over the log of 2. Okay, when t goes to infinity, where is this going?
0.
Because it's in terms of u. U is the log of x, so it's the log of 2 and the log of infinity. All right? Because I still have a u here. That's why I changed the limits to be in terms of u. Okay, t is going to infinity, so that's 0. So we're going to have negative 0 minus 1 over the log of 2, which is 1 over the log of 2. All right. Now, you could have switched back to 1 over the log of x. You could have made it 1 over the log of x from 2 to infinity, from 2 to t. That works too. All right. Either way, gives you the same answer. Okay. Okay, who's ready for number 3? Okay, if you have an improper integral, you're going to have to take the limit. Introduce a new variable and take the limit. That's improper integrals. All right, so we want to find the sum of this series, and how many people think this is telescope?
No, it's the first one is using e to the x, and the second one is 1 over 1 minus x.
Well, yeah, somebody recognize that this is an exponential. Remember, e to the x is the sum, n equals 0 to infinity, x to the n over n factorial. So what is x in this case?
1/2.
X equal 1/2. It looks like my pen is dried up. So we'll have 1 over 2 to the n factorial. So that's just e to the 1/2. Okay, the second one is definitely a geometric series, but we just want the sum. Do you remember how we get the sum? I can write that as 1/2 to the n. Okay, remember we call this the ratio, and if the ratio is less than 1, what's the sum going to be?
First term divided by 1 minus the ratio.
Minus the ratio, exactly. So our first term starts at n equals 0. That's really important. So we'll have 1/2 to the 0 on top, and the ratio is 1/2. So that's going to be 1 over 1/2, and this will become what? 2. So we have e to the 1/2 plus 2. Questions on that one?
Could you use that the 1 over 1 minus x?
We wanted the
To-
sum here. The question asked for the sum. So
Oh, no, but I mean, like, what I did on my process was like that's basically the same form as like the power series of 1 over 1 minus x. So I plugged in 1/2 and it worked.
okay, oh yeah, I see what you're saying. 1 over 1 minus x is sum n equals 0 to infinity x to the n, and you just plug in 1/2. You're going to get exactly the same thing. Yes. Yeah, you could have done that too. Okay, with telescoping, we have something that's sequential. We would have like an n and n plus 1. What would you do if you didn't see the e to the x? You'd probably miss it. You need to train yourself to look for these patterns. And remember, it's the denominator usually that tells you what kind of series you have. And if you look on your cheat sheet, you'll have n factorial, the denominator is an exponential. Okay? These are in the spring 16 final. I sent it out to you guys. If you're in Dr. Manley's class, if you're in my class, it's on the exam review page. Okay, you notice that x equals 1/2, so you just plug in 1/2. That's 1 over 1/2, which is 2. Okay, and that's the same thing. Where does the factorial come from? This is the Maclaurin for e to the x. And we have something over n factorial, okay? Oh, no, this just works for the second term. This term you use the Maclaurin for exponential. This term you use geometric series, okay? All right, let's move on to number 4. Okay, if sum n equals 0 to infinity, c sub n x minus pi over 3, the n is the Taylor series for f of x is sine x, and the center a is equal to 3. That says center. Let's find c sub 3. Okay, and for Taylor series, c sub 3 is going to be the third derivative at a times x minus a cubed over 3 factorial. Okay, so we need the third derivative, and a is pi over 3. Okay. I'm sorry, c sub 3 is just this part. We don't need this part. Okay, so f is sine x. What's f prime? Cosine. F double prime is negative sine, and the third derivative is negative cosine. So c sub 3 is going to be negative cosine at pi over 3 over 3 factorial. What's the cosine of pi over 3? And we have a negative in front of it. That's going to be 1/2 over 6. So you should have negative 1 over 12 as your answer. Okay. Okay, we're ready for number 5? Yeah, we just use the Taylor coefficient. Okay, which one of these is divergent? Okay, which one is different out of all of these? And I didn't put where they start because it's kind of irrelevant to the problem, except for, well,
Cosine.
yeah, I'm going to start with the one that's different. Okay, and when we see tangent and sine, we know these are going to be limit comparison. Okay, so let's try limit comparison here. So my process is this, D is the different one. So if we do limit comparison here, what are we going to use for B sub n? An is 1 over n times the cosine of 1 over n squared. What will we use for B sub n?
1 over n squared.
1 over n. And remember, n's going to infinity. So what do we want to use here? Do we want to use the cosine of 1 over n squared or 1 over n squared? Just 1. Okay. All right. Now, what do we know about B sub n? What kind of series? It's a divergent harmonic series. Divergent harmonic series. All right. Now, we'll see what happens when we look at the ratio of A sub n over B sub n. Okay. And what's going to happen? If it's finite, what does it mean? That what B sub n does, an does too, right? Okay, so when we take this limit, 1 over n cosine 1 over n squared over 1 over n, these two will cancel, right? And what's this limit going to give us? This is like the cosine of the limit as n goes to infinity of 1 over n squared. And where's that limit going? It's going to 0, right? And that's the cosine of 0, which is 1. Now, is 1 a finite value? This is finite. So what did we say here? Whatever Bn does, An does too. What does Bn do?
Diverge.
Bn diverges, so An diverges too by limit comparison test. Okay, so that was a pretty good guess. Yeah, pretty much sine or tangent, but before I move on, let me write down, what are we going to use for B sub n for part A?
Still 1 over n.
It's
Right.
squared here,
Oh,
1 over n squared, right? What about this one?
1 over n squared as well.
N squared as well. What about this one? 1 over n times 1 over square root of n, okay? And you can write that as 1 over n to the 3/2. What about this one?
1 over n.
N times 1 over n cubed, which is 1 over n squared. But it's a good idea to leave it like this when you take the limit because it's easier. Okay, because I know that sine and tangent are LCT series. Cosine usually isn't. Okay. Because tangent and sine have something in common. Okay, tangent is sine x over cosine x, right? And as x goes to 0, sine x goes to 0, tan x also goes to 0, right? And this is why we can use them with limit comparison. On the other hand, as x goes to 0, cosine of x goes to 1. So it's not going to have the same behavior. Why is a 1 over n squared? Okay, because we replace the tangent function with the function itself. Okay, and we can write this as the tangent of 1 over n times the tangent of 1 over n. And for limit comparison, we're just replacing tangent with the argument to tangent. Okay. All right. Okay, who's ready for number 6? What about B? Oh, I made a boo-boo. That should be 1 over n squared. Replace the sine function with the argument to the sine function. Okay. Okay, are we ready for number 6? Y for E. Okay, we have to keep the n, but we replace the sine function with the argument to the sine function. Okay, we have to keep this guy. Oh, because I know that as it goes to infinity, the cosine of 1 over n squared will go to 1 because of this. All right. Yeah, this is Calc 1 stuff, and we expect you to know it. If you don't remember your limits, please review them. Okay. Yeah, the log of the limit is the limit of the log. That works too. How I got n? Which n? Which b sub n? The one for D? For which? A, B, C, D, or E? Okay, for limit comparison test, you're gonna, if you have sine or tangent, you're gonna replace sine or tangent with its argument. Since we had squared here, we have 1 over n times 1 over n, which is 1 over n squared. For this one, replace sine 1 over n squared with 1 over n squared. For this one, we have to keep the 1 over n, that's this one, but we replace tangent with its argument. No, I have not. Okay, I'm not going to do the rest of them because it's kind of redundant. I explained where the D came from. All right, let's move on to number 6. How are we going to find this shaded area? Okay, this is the flat curve. This is R versus theta. And this is X and Y. Okay, does anybody know how we're going to figure out how to calculate that shaded region? Well, first of all, can you look at this graph and tell what are these angles?
Pi over 2 and 0.
Well, this one is pi over 2. Okay, but at 0, R of 0 is going to be 2 times the cosine of 0 plus 0. That puts us down here. So this is our start point. I'll call that A. And that corresponds to 0, 2 on the flat curve. Okay, so we're going to be going in this direction. And at pi over 2, we have a value of 2. So that corresponds to point B on the flat curve. Okay. So we know that this angle is pi over 2. Okay, down here, what is the radius at this point? I'll call that point C.
0.
The radius is 0 at C. So that corresponds here. Now, how are we going to find the angle that corresponds to an R equals 0?
Plug it into the
Plug it into the
formula.
formula. Okay. So over here, we're going to say that 2 cosine theta plus 2 sine theta is equal to 0. I can cancel the 2's to get that sine theta is negative cosine theta, or tangent theta is equal to -1. Okay, so we're looking for an angle between pi over 2 and pi that has a tangent of -1. So who can tell me what that angle is? 3 pi over 4, precisely. Okay, so those are our limits. So our area is going to be 1/2, and we're going from pi over 2 to 3 pi over 4. Okay, what goes inside? R squared. 2 cosine theta plus 2 sine theta squared d theta. Okay, we're going to have to FOIL this. So we'll have 4 cosine squared theta plus 8 cosine theta sine theta plus 4 sine squared theta d theta. Okay, what do these two guys give us? 4 cosine squared plus 4 sine squared times 4, which is 4, right? Okay, so now we're looking at 1/2 pi over 2 to 3 pi over 4. 4 plus 8 cosine theta sine theta d theta. Okay, now what I want to do is pull out the 4. So that we'll have 1 plus 2. I can write that as sine theta cosine theta d theta. Okay, now we can directly integrate. Does anybody remember what is 2 sine theta cosine theta equivalent to?
Sine squared.
That's the sine of 2 theta, correct? Right, so let's integrate that. This will become a 2. We'll get 2 times theta plus or minus, it's going to be minus cosine 2 theta over 2. And we have to evaluate between pi over 2 and 3 pi over 4. Okay, so that's going to give us 2 times 3 pi over 4 minus pi over 2 minus 1/2, and we'll have what? Cosine 3 pi over 2 minus cosine pi. Make that a square bracket. Okay, when that simplifies, you'll have 2 times pi over 4. This will be 0, and this is a plus 1. We'll end up with 1/2. And this will simplify to pi minus 2 over 2. Okay. Questions on that one?
How did you connect like the graph on the right to the graph on the left?
Okay. Here, the theta is on the horizontal axis and the r is on the vertical axis. And this is the XY plane. Okay, so when r is equal to 2 and theta is equal to 0, our angle, we're rotating 0 degrees from the x-axis, but the radius is 2, so that puts us at 0.8. Do you see that?
Yes.
Okay. And now what's happening? The radius is getting bigger as we rotate in the positive theta direction until we get to pi over 2, where the radius is exactly 2. Okay.
Mm-hmm.
I know that that angle is pi over 2. You can see it, right?
Yeah.
Okay. And you know that the radius is 2 because we have 2 tick marks. Okay. Where did I get the 1/2 when plugging in? You mean right here? Pi over 2. Because this shaded region, it starts at pi over 2 and it ends at this angle. The lower bound is pi over 2. I don't know what you mean. What you mean something different? No lower. You mean this? Where did this come from? Where?
Kind of a little bit to your right, like where that 1/2 it says negative 1/2. Or is that just you taking out
This
1/2?
is a negative 1/2, right?
Oh, gotcha. Okay, thank you.
Okay. All right, let's move on to number 7. Okay, how are we gonna, log is an inverse function, so how are we gonna integrate this?
Integration by parts.
By parts, correct. Okay, and we're just gonna put the entire log here. Okay, so if the log goes under the D column, what's gonna go under the I column?
dx.
Yeah, or just 1. And remember, I'm using IPET, inverse function always goes to the left. Or log, okay? All right, what's the derivative of the log of x squared plus 4? That's going to be 2x over x squared plus 4, correct? And the integral of 1 is x. So we'll have plus, minus. So I'm going to pretend like I don't have limits of integration for the moment. So this is going to give us x times the log of x squared plus 4. And then we're going to have to integrate the product here with a negative sign in front of it. So we have minus 2x squared over x squared plus 4. All right, now I'm going to do some tricks here. God. See, I have a built-in alarm system. Okay, it's going to be about an hour and a half. It takes an hour to process after I finish. Okay, what I'm going to do here is pull out the 2. I'm going to pull this 2 out. Okay, now I'm going to do something tricky. Yeah, that's x squared. 2x times x is x squared. Okay, what did you think it was? Okay, now I'm going to rewrite this. I'm going to rewrite this as x squared plus 4 over x squared plus 4. Because I'm adding 4, I'm going to subtract 4. Okay, it's the same thing. I'm just putting it in a form where it's easier to integrate. Now, what does this become? That's just 1, right?
Yes.
Okay. So this is going to give us x times the log of x squared plus 4 minus 2 times, when I integrate 1, I'll get x. And what am I going to get when I integrate this? This is going to be arctangent, right? It's going to be negative 4 over 2 arctangent of x over 2 plus the constant integration. All right, let me clean that up a little bit. I'm going to distribute the 2. So I'll have minus 2x, and that's going to be positive 8 over 2. Okay, now we can apply our limits of integration, which are 0 to 2. Okay, so we'll have 2 times the log of 4 plus 4 minus 4 plus 4 times the arctangent of 1. And then we're going to subtract 0 minus 0, and 4 times the arctangent is 0. Okay, so that's going to give us 2 log 8 minus 4. And what's the arctangent of 1? Pi over 4, right? Now, I can rewrite 8 as 2 times the log of 2 cubed minus 4, and this will be plus pi. Now, what can I do about this 3? I can pull it out and put it in front of the 2, right? So then this will be 6 times the log of 2 minus 4 plus pi. And that should be your answer. Unless I made a subtraction error somewhere. Okay. Do you remember what this is? 1 over a arctan x over a plus a constant. You need to know that. That was on your first exam. Okay, that's the shortcut. You can also do it with a trig sub. Okay, I'm sure you've seen this before. If you're in my class, we saw this before. Where did the x over 2 come from? Which x over 2? Oh, here. A is 2 in this formula. 4 is 2 squared, okay? You see 4 is equal to a squared, a is equal to 2. All right? That's from applying this formula. Okay?
Can you clarify how you rewrote x squared over x squared plus 4?
Oh, yeah, I just wanted to write, okay, your alternative to doing this is long division. Do you like doing long division? I just wrote it as a form of 1 and I made adjustments. Okay, do you see how they both have a denominator of x squared plus 4? And what is x squared plus 4 minus 4? That's just x squared, right?
Oh, okay, I see it now.
All right. If you prefer to do long division, be my guest. But you will come up with 1 minus 4 over x squared plus 4 if you do it correctly. All right. Okay, who's ready for number 8? Okay, we've got a parametric curve and we've got to decide whether these statements P, Q, and R are correct or true or false. So a point on the ellipse moves clockwise as t goes from 0 to pi. How are we going to figure that out? Okay, so let's do part P. And the way I'm going to figure that out is to make a table. Okay, for t, and then we have x is 2 times the cosine of t. And y is 4 times the sine of t. And when t is equal to 0, what do we have? Cosine of 0 is 1, so we'll have 2. Sine of 0 is 0. Okay, now let me put t is pi over 2. X will be 0. Y will be 4. When t is equal to pi, what's x going to be? Negative 2. Y will be 0. And at 3 pi over 2, 0, negative 4. That's probably enough. So let's plot what we have here. Okay, so we're starting at 2, 0. This is x and this is y. So that's A. All right, now we move to pi over 2. We're at the point 0, 4. So we're going in this direction. Is that clockwise? Is this clockwise?
No, that's counterclockwise.
Counterclockwise. All right, so is P true or false?
False.
It's false. Okay, the next statement Q, C is decreasing when t is between 0 and pi over 2. Okay, what does it mean when a curve is decreasing?
It's negative.
It means that the derivative is negative. So we need to check the sign of dy dx, but first we have to find dy dx. So for Q, dy dx is going to be dy dt over dx dt. And dy dt is going to be 4 cosine t. Dx dt will be -2 sine t. That's going to give us -2 cotangent t. Okay, and let's just pick a value in between these two. I'm going to evaluate at t equal pi over 4. And that's going to give us -2 times 1, which is -2, which is less than 0. So are we decreasing when the first derivative is negative? Is Q true or false? It's true. Okay, the last question is R. C has 2 horizontal tangent lines at t equal pi over 2 and t equal 3 pi over 2. Well, you can just look at that. Is that true or false? You're going to have that cosine of t is 0 in both cases, right? That's true, right? If the numerator is 0 and the denominator is not 0, what does that give us? Horizontal tangent line, right? So this is true also. Why did I evaluate it pi over 4? Because it's in between the ends of this interval. Okay. Do you see the interval stated was 0 to pi over 2? So I plugged in something in between those two. Okay. So everybody okay with this horizontal tangent line? All right. Are we ready to move on to number 9? Okay, what's number 9? We want the interval of convergence for the log of n over n squared. Okay, first we're going to do the ratio test. So we take the limit as n goes to infinity, log of n plus 1 over the log of n plus 1 squared over n squared, 2x minus 1 to the n plus 1 over 2x minus 1 to the n. And we don't need the absolute values. Okay, where is this ratio of logs going? This is an n.
1.
1. And so is the polynomial degree is 2 for both cases. Both have a leading coefficient of 1. And so this is telling us that the absolute value of 2x minus 1 has to be less than 1 for convergence. Okay, and I'm going to turn that into a 3-way inequality. -1 is less than 2x minus 1. And less than 1. The next thing I'm going to do is add 1 to all 3 pieces. We'll have 0 is less than 2x is less than 2. And then I'm going to divide all 3 pieces by 2 to get 0 is less than x is less than 1. Okay, now we need to check both ends of the interval. Okay, when x is equal to 0, we're going to plug 0 in here and we'll get sum n equal 2 to infinity log n over n squared times -1 to the n. Now, is this series converging or diverging, and by what test?
Converging by AST.
All right, right? We have this part is we have an alternator. This part is decreasing. The limit is 0 as n goes to infinity, so it converges by alternating series test. Okay, what about x equal 1? We'll have sum n equal 2 to infinity log of n over n squared. 2 minus 1 will have 1 to the n. What's this one doing?
Gonna converge.
Does this converge by the p-test?
Yes.
We can write that as n squared times the log of n to the -1. So our interval is going to be 0, 1. Okay. Okay, number 10. This is going to be a Maclaurin problem. We're going to approximate this integral with the first three non-zero terms. Okay, so we're going to start with Maclaurin for cosine x, which is what? -1 to the n, x to the 2n over 2n factorial. But we have the square root of x, and that will become -1 to the n, x to the n over 2n factorial. And when we put an x in front of it, that's going to be x to the n plus 1. Okay, and let's write out some terms. When n is 0, we'll have x. When n is 1, we'll have minus x squared over 2 factorial. Then we'll have plus x cubed over 4 factorial minus x to the 4 over 6 factorial, and so on. Okay, now let's have x minus x cosine root x. That's going to be x minus x plus x squared over 2 factorial minus x cubed over 4 factorial plus x to the 4th over 6 factorial, and so forth. So these two will cancel, right? Okay, now let's integrate this from 0 to 0.1, x squared over 2 factorial minus x cubed over 4 factorial plus x to the 4th over 6 factorial, and so forth. Is the x to the 4th part the 4th term? 1, 2, 3, 4. Yeah, I took out an extra term. You don't need the 4th one. I just took out an extra one, okay? All right, so what are we going to get when we integrate this? The radical x. If I replace x with x to the 1/2, x to the 1/2 raised to the power 2n, what's that just the same as x to the n? Because 1/2 times 2n is just plain n. Okay? Is that okay? How the x in front of the cosine? When I multiply by x, that's just raising it to the power 1. I'm multiplying it by x. I just took it out another term. You don't have to, but I did. Okay? All right, let's integrate this. What do we get when we integrate this? It's going to be x cubed over 3 times 2 factorial minus x to the 4th over 3 times 4 factorial plus x to the 5th over 5 times 6 factorial. Oh, this should be a 4, shouldn't it? All right. So why did you bring the ln down and make the power negative? Why did I bring what ln down? Because the ratio test is the limit of the n plus 1th term over the nth term. Okay? Oh, here? Because log x over 1 is the same as 1 over log x to the -1. Okay? So you could apply the p-test. Okay, I don't know whose class you're in, but this is the way we do it in Manly's. Okay. All right, let me move on. All right, we want to evaluate this between 0 and 0.1. Okay, so when we plug in 0, we get nothing. We'll have 0.1 cubed over 3 times 2 factorial minus 0.1 to the 4th over 4 times 4 factorial plus 0.1 to the 5 over 5 times 6 factorial. Okay, and I think that's the first 3 non-zero terms that are left because these guys cancel. Pretty sure that's the answer. Okay, number 11, let's find the Maclaurin for f is x over 2 plus x squared. And I'm going to rewrite f as x times, I'm going to pull out a 2, so it'll be 1 plus x squared over 2. So that's going to be x over 2 times 1 over 1 minus negative x squared over 2. And I can write that as x over 2, sum, n goes from 0 to infinity. We'll have negative 1 to the n, x to the 2n, over 2 to the n. Okay? Okay, now we want to find the radius of convergence. So I'm going to do, oh, and let me bring those in. So when we bring those in the summation, we'll have negative 1 to the n, and the power on x will be 2n plus 1, and the power on 2 will be 2n plus 1. Okay, now we'll do a ratio test. We'll take the limit as n goes to infinity of the n plus 1th term over the nth term. So it's absolute value, we don't need the alternator. So we'll have x to the 2 times n plus 1 over x to the 2n plus 1. And we'll have 2 to the n plus 2, 2 to the n plus 1. Okay, this becomes 2n plus 3. So that's going to give us x squared over 2. And we want that to be less than 1. Okay, so another way of saying this is that negative 1 is less than x squared over 2 is less than 1. We can multiply all 3 sides of the 3-way inequality by the denominator to get negative 2 is less than the absolute value of x squared is less than 2. And finally, we can take the square root of all 3 sides. Negative root 2 is less than x is less than root 2. So what's the radius of convergence? Root 2, right? Okay, number 12. Okay, the integral from 0 to a 1/2 of 2 sine 3 theta squared d theta is the area of this pedal. So what is the upper limit of integration? What's the value of r? We start out down here, we come up this pedal and then come down. What is the value of r when we come back down?
It's 0, so theta is 5 over 3.
Right, we're going to have to let 2 sine 3 theta equal to 0. Now that means the sine of 3 theta is equal to 0. Okay, when is theta equal to 0? When is sine equal to 0? 0, pi, 2 pi. So, I'm sorry, that's 3 theta. So 3 theta is equal to 0, pi, 2 pi. And that means that theta is 0, pi over 3, 2 pi over 3. Okay, which one is the correct one? This is what we start with. So we're starting down here, we're coming back up. So the next one that we hit is pi over 3. Okay, when is the sine equal to 0? This is a graph of the sine function. Do you remember when the sine is 0? When theta is 0, pi, and 2 pi, right? And on, okay. Oh, because what is the value of the radius at this point? The radius is how far you go out from the origin. It's 0. That's why we set it equal to 0. Divide both sides by 2. We've got sine 3 theta is 0, right? So what is the value of 3 theta when sine is 0? Okay, we're just solving for what angle gives you sine of 0. Okay, So this is your answer, pi over 3. Okay. Okay, now 13, I changed it. In the original 13, they wanted you to rotate about x equal 2, but we didn't cover that in Dr. Manley's class. So do you remember how to use the shell method? Okay, remember the area or the volume, I'm sorry, the volume is going to be 2 pi times some integral from a to b, a shell radius times a shell height. Okay, so I'm going to draw the reflection as we're rotating about the y-axis, and I'm going to draw a shell in here. Okay, so here's our shell. Okay, does anybody remember what is the radius of the shell? If this is x and this is y, what did we call this distance?
X.
The radius is just plain x, right? And what's the height? It's the upper function minus the lower function, right? Right. Okay, which one's upper and which one's lower?
Root x is upper.
Yeah.
Okay, it looks like the upper one is the square root of x. And the lower one is x squared. Okay. So that's going to be 2 pi x times root x minus x squared dx. Okay, and what are our limits of integration? Okay, we're integrating with respect to x. So what's x over here?
0,
And what is the value of x when these two functions are equal?
1.
1. All right, that's it. All right, if you can't tell which one's upper and I think we had a picture for this one, but if you can't do, just plug in a number in between the intersection and see which one's higher. Okay, that brings us to your favorite thing, trig sub. Do you remember how much you love trig sub? Okay, if we're doing shell method, we would do, if we had something like this. Okay, V would be 2 pi r y h of y dy. Okay. All right, so
But I thought
this
we
is
were
gonna be
doing
a
shell
trick
method
sub.
on the top part.
What was that?
But I thought we were doing shell method on the top part too.
We did shell method, we just needed to set it up. Somebody asked what would happen if you were rotating about the x-axis, and this is what you get if you rotate about x.
Oh, okay. Thank you.
It's not the same functions, different functions, okay? Oh, it could be the same, I'm sorry. You could rotate this about x as well. I don't know what letter this is. Okay, or you could do this with washers too. I didn't write down the answer choice. I'm sorry. I have no idea. Okay, let's move on to this one. How are we going to solve this? This is a trig sub. You have the variable squared minus a constant. Oh, that depends on the problem. Sometimes it's easier with shells. Sometimes it's easier with washers. Do the one that's easier to integrate, unless they're just asking for the setup. You know, it's not necessarily that it always goes one way when you rotate about one axis and another way when you rotate about the other. It really depends on what your functions are. Okay, anybody remember what's the trig sub when it's the variable squared minus the constant squared?
A secant theta.
Yeah. Okay, it's going to be a secant. So we're going to let 2x be the secant of theta. All right. So 2 dx is going to be secant of theta, tangent theta, d theta. So when we plug that in, this means that x is the secant of theta over 2. So let's plug that in. It's going to give us 8 over the secant cubed of theta for this part. And for this part, we'll have the square root of secant squared minus 1. And dx will be secant theta, tangent theta, d theta divided by 2. Okay, so the 8 and the 4 can cancel, and I'm going to pull out a 4. And can we cancel? Oh, and what do we get here? Secant theta, tangent theta, d theta over secant cubed theta. And what is the square root of secant squared minus 1?
Tangent theta.
That's tangent theta. All right. But remember, you need these identities. Sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. And cotangent squared plus 1 is cosecant squared. Although we don't use this last one. All right, now what can we cancel out?
Secants and tans.
The tans will cancel, and one of the secants will cancel, and we'll have d theta over secant squared. And what is 1 over secant squared?
Cosine squared.
So we'll have 4 cosine squared theta d theta. Now what's the identity? We're going to use the half angle. So we'll have 4 over 2, 1 plus cosine 2 theta d theta. And when we integrate that, we'll have 2 times theta plus sine 2 theta over 2. That's a constant. Okay, and what's an identity for sine 2 theta? I think we've already used it today.
Yeah.
2 sine theta
2.
cosine theta, right? So we'll have 2 theta, and then these 2's will cancel. We'll have plus 2 sine theta cosine theta plus c. All right. Now, we need to put this back in terms of x. So what do we do? First thing, what is x? So secant theta is 2x. That means that theta is the arcsecant of 2x. All right. So that's going to give us this, and then we need to make a triangle. Okay, so theta is the arcsecant of 2x, and that's going to be the hypotenuse over the adjacent. And so the opposite side we can calculate. That's going to be the square root of this side minus 1. This side squared minus 1. Okay, so what is the sine of theta? Opposite over adjacent. That's the opposite over hypotenuse. And what's the cosine of theta? Adjacent over hypotenuse. So we can plug those in. We'll get 2 times the arcsecant of 2x, and then we'll have 2 times the sine of theta, which is square root of 4x squared plus 1 over 2x, times the cosine of theta, which is 1 over 2x. So this will be 2 times the arcsecant of 2x plus the square root of 4x squared plus 1 over 2x squared plus a constant. This should be it. Okay. How do you make the triangle again? Okay, you're going to put the right side, the right angle on the right, put theta to the left, and arc and secant is hypotenuse over adjacent, right? So the secant of theta is 2x over 1, and that's the hypotenuse over the adjacent side. Okay, hypotenuse over adjacent. Then you have to calculate the third side from the Pythagorean theorem, or it usually turns out to be your original radical if you've got a radical. Okay? So you label the two sides based on your initial substitution, and then you can calculate the third side from the Pythagorean theorem. Okay, are we ready for the next one? I hope so. Okay, what are we going to do here?
Partial fraction
Partial
decomposition.
fractions, yeah. 1 over x squared minus 4 is going to be, we fully factor. And then we're going to do partial fractions. Okay, we can do cover up for both of these. We're going to cover up a's denominator and plug in the value of x that makes it 0. So a will be 1/4. B, we're going to plug in -2, and we'll have -1/4. So this is like integrating from 3 to 4. They both have a 1/4, so I'll pull that on the front. So we'll have 1 over x minus 2 minus 1 over x plus 2. Okay, and when we integrate that, these will just be logs. Cover up. Okay, so you're going to cover up a's denominator and stick in the value of x that makes the denominator 0. So you're going to plug in 2, okay? No, because 1 over 2 plus 2 is a positive 1 over 4. Okay, for B, the value of x that you plug in is -2. You're going to plug in b's, cover up b's denominator, plug in -2. All right. Okay, and when we integrate this, we'll get 1/4 times the log of x minus 2 minus the log of x plus 2. Okay, and I can rewrite that using the rule of logs. X minus 2 over x plus 2 from 3 to 4. And that's going to be 1/4 times the log of 4 minus 2 over 2 plus 2 minus the log of 3 minus 2 over 3 plus 2. And that's going to give us 1/4 times the log of what? 2 over 4, which is 1/2, minus the log of 1 over 5. Uh-oh, I think I messed something up.
Yeah, your denominator should be 4 plus 2 for the first one.
Okay, yeah. So that should be 2 over 6, right?
Mm-hmm.
Which is 1 over 3. I'm sorry. And then this one should be 1 over 5. Okay, and I can write that as 1/4 times the log of 1/3 over 1/5, which is 1/4 times the log of 5 over 3. I forgot the log part. Okay. Yeah, thank you. Okay, so you need to know how to manipulate your logs. Okay, anybody ready for number 16?
Yeah.
We want to find the volume of this solid when cross-section perpendicular to the x-axis are semicircles. Okay. So I'll call that A of x. So how do we describe the area of a semicircle? It's going to be half of pi times the radius squared, right? What's the radius going to be? If this distance is 2 sine theta, the radius is going to be just plain sine theta, right? Okay. And now to get the volume, we're going to integrate that. 1/2 pi sine squared x dx. And what are our limits of integration? We're going from 0 to
Pi.
pi. So I'm going to pull these out. We'll have 1/2 pi, 0 to pi, sine squared x dx. Okay, is there an identity we can use here?
Angle.
Right, we're going to write that as 1 minus cosine 2x over 2. And when we integrate that, we'll have 1/2 pi x over 2 minus sine 2x over 4, right? So that's going to be 1/2 pi over 2 minus sine 2 pi over 4 plus sine 0 over 0. These are both 0. So this is going to give us pi squared over 4.
What happened to the 2 that's in front of the sign? Because it's y equals 2 sine x.
Oh, because the radius, we're looking for the radius, right? The radius of a semicircle is half of that height, right?
Right.
So it's
Got
not
it.
2 sine x, it's sine x.
Okay, thank you.
All right, number 17. Okay, this is an arc length problem. Do you remember the formula for arc length? You just had this on your exam. Okay, it's going to be arc length A to B square root of dx dt squared plus dy dt squared dt. So what's dx dt? Have to use the product rule. It's going to be sine t plus t cosine t. And for dy dt, it's going to be cosine t minus t sine t. Now when we square them, we'll have sine squared t plus 2t sine t cosine t plus t squared cosine squared t. And dy dt squared is going to be cosine squared t minus 2t sine t cosine t plus t squared sine squared t. Okay, and when we add them, okay, we'll have sine squared t plus cosine squared t. What's going to happen to those? They cancel. And here we'll have cosine squared t plus sine squared t. And who can tell me what this will become?
1.
What's the answer for the last one? I squared over 4. All right, this is 1 and this is 1, so you get 1 plus t squared. All right, we're told that the limits on t are 0 to 1. So we have 0 to 1 square root of 1 plus t squared dt. Oh my goodness, how are we going to integrate that? This is your favorite thing.
Trace
Trig
up.
stuff, right?
Again.
And when you have a plus sign, it's going to be tangent. We're going to let t be the tangent of theta so that dt is secant squared theta d theta. So I'll pretend like I have an indefinite integral for now. Well, the square root of 1 plus tangent squared t theta secant squared theta d theta. What does the radical become? That's going to be the square root of secant squared theta d theta, and that will become secant cubed theta d theta. Okay, and you all remember the integral of secant cubed, right?
Yeah.
That's going to be 1/2 of the derivative, which is secant theta tangent theta, plus the integral, which is what? The log of secant theta plus tangent theta. All right. Okay, now what? triangle, right? We got to do the triangle. So if the tangent of theta is t, I can write that as the ratio of t over 1. And here's theta. Okay, the tangent is the opposite side, which is t, over the adjacent side, which is 1. What's the remaining side going to be? Square root of t squared plus 1, right? Okay, so what is the secant of this triangle? Secant is root t squared plus 1. Tangent is t. And then we'll have log root t squared plus 1 plus t. And we need to evaluate this between 0 and 1. So that's going to be 1/2 times, when t is equal to 1, we'll have root 2 times 1 plus the log of root 2 plus 1 minus root 1 times 0 plus the log of root 1 plus 0. All right, the log of 1 is 0, that's 0. So we'll have 1/2 times root 2 plus the log of root 2 plus 1. Okay? I don't think you're going to get anything this long in Dr. Manley's class. But it's a good review of tricks. Though. Okay, we're coming close to the finish line. Okay, this is an n in the numerator, and we want to know if it converges or diverges, and we also want to know what test do we use.
That one converges by AST. Oh, no, it doesn't.
Okay, remember the hierarchy of functions. The log of n to the p is less than n to the q, is less than a to the n, is less than n factorial, is less than n to the n. So who's growing faster, the numerator or the denominator?
The numerator.
Okay, this is growing faster. So the numerator is growing faster than the denominator. So what's this series going to do? If we look at the part without the alternator, if the numerator grows faster than the denominator, this limit goes to infinity, right?
Mm-hmm.
So it diverges, but by what test?
Test of divergence.
Test for divergence. Okay, don't be fooled by the alternator. Now, why couldn't we use the ratio test here? What would we get?
You get 1 for that.
We'd get 1 if we use ratio test. This would be useless. Okay, all right. And these have to be positive. P, Q, A, N, all positive, okay? Yeah, so n to the 0.00001 grows faster than the log of n to the 9999999 eventually. Okay, because what are the conditions for AST? Do you remember what alternating series told us? Okay. That this is decreasing, which is a lie. And we also have that the limit as n goes to infinity of n over log squared equals 0. That's also a lie. We didn't satisfy either one of these conditions. Okay? Because the numerator is going faster than the denominator. All right? So this is your answer. Diverges by test for divergence. Okay. Yeah, if you call this part B sub n for AST, we need B sub n is decreasing and limit as n goes to infinity of B sub n equals 0. We need those two things for convergence. All right. Number 19, we're almost done. Okay, what are we going to use for this one? Converge or diverge? This is going to be comparison test because we know, what do we know about the sign of n?
It's less than or equal to 3 over.
Right, sign is
three.
always
Oh,
trapped between -1 and 1. Now let's add 2 to each piece. So this tells us 1 is less than or equal to 2 plus the sign of n is less than or equal to 3. Okay, now we can divide each piece by the denominator, which is 3 to the n. Okay, if we want to show something that converges, you compare to something larger that converges. So which one is larger, this one or this one? This one's the larger one, right? Now let's take a look at that series. 3 over 3 to the n, that's 3 times 1/3 to the n. Okay, what do we know about this series? That's absolute value 1/3 is less than 1. You raise something that's less than 1 to a power of n, what do you get? That's a convergent geometric series, right? Yeah, you'll get 0 when you take the limit, but we know this is a convergent geometric series, right? So if this one converges and it's bigger than this one, what does the comparison tell us about this one? It's going to converge by direct comparison, right? Direct comparison test. All right. Okay, number 20. What about this one? Converge or diverge? Generalized p-test. Converge. But if that's not an answer, which one are you going to pick? The generalized p-test is a consequence of which of these?
Integral.
Integral, correct. And if you didn't remember, you could do the integral test here and you could find that it comes out to a finite value. In fact, I worked it out, but we've already gone way over an hour. Okay, number 21. This is a sequence. Which sequence diverges? Okay, and if you got sharp eyes, you don't have to actually work them out. I know already. I'm going to rewrite this as 9 to the n over 4 to the n. And that's 9 over 4 to the n. And this is greater than 1, right? So if we take the limit as n goes to infinity of something that's greater than 1 going to the power n, what's that limit going to be? Infinity, right? So this one diverges. So if you can find the one that sticks out right away, that'll save you some time. Okay, one more, and this is a giveaway. What's the best way to integrate this integral? It's 2 steps. What will you do first? U sub, where u is e to the x. What do you do next? You get cosine square u du. What do you do with this guy? We've done it a couple times, half angle. Cosine squared is 1/2 times 1 plus cosine 2. That's u. All right, excellent. We're done. Okay, any questions? Thank you for coming.
Thank you.
Okay, and I'll see you guys on Wednesday, same time. I'll send you the link. All right, thank you for coming and good luck. See you Wednesday.